The new reference in 800.24 of the National Electrical Code subjects all communication circuits to the same wiring methods as power circuits. This implies that communication cables must be installed in a neat and workmanlike manner, be supported securely, and be protected from damage. The intention of this new requirement is to enhance the safety and reliability of communication systems. In the past, the installation of communication cables was often performed haphazardly, which could result in damage and outages. This new requirement will help guarantee that communication cables are installed properly and safely. However, the new requirement does not apply to all communication circuits. For example, this requirement does not apply to communication cables that are installed in plenum spaces. Plenum spaces are defined as air handling spaces that are used to distribute conditioned air to occupied spaces. Communication cables installed in plenum spaces must adhere to the requirements outlined in section 800.22 of the NEC. It is also important to remember that the new requirement does not apply to communication cables installed in existing buildings. However, any communication cable installed in an existing building must comply with the requirements of the NEC that were in effect when the building was originally constructed. Section 800.24 of the National Electrical Code addresses the mechanical execution of work related to communication circuits. It mandates that communication circuits and equipment be installed in a neat and workmanlike manner. Cables installed exposed on the outer surfaces of ceilings and sidewalls must be supported by the structural components of the building in a way that prevents damage from normal building use. These cables must be attached to structural components using straps, staples, hangers, or similar fittings designed and installed to avoid cable damage. The installation must also comply with sections 300.4 D and 300.11 of the NEC. Section 300.4 D pertains to cables and raceways that run parallel to framing members. In both exposed and concealed locations, when a cable or raceway type wiring method is installed parallel to framing members like joists, rafters, or studs, it must be installed and supported so that the nearest outside surface of the cable or raceway is at least 32 mm, which is 1¼ inches, from the nearest edge of the framing member where nails or screws are likely to penetrate. If this distance cannot be maintained, the cable or raceway must be protected from penetration by nails or screws using a steel plate sleeve, or equivalent that is at least 1.6 mm, which is 1/16 of an inch thick. There are a couple of exceptions to this rule. Firstly, steel plate sleeves or equivalents are not required to protect rigid metal conduit, intermediate metal conduit, rigid non-metallic conduit, or electrical metallic tubing. Secondly, for concealed work in finished buildings or finished panels for prefabricated buildings where such support is impractical, it is permissible to fish the cables between access points. Section 300.11 covers the securing and supporting of raceways, cable assemblies, boxes, cabinets, and fittings. These components must be securely fastened in place. Support wires that do not provide secure support are not permitted as the sole support. However, support wires and associated fittings that provide secure support and are installed in addition to the ceiling grid support wires are permitted as the sole support. When independent support wires are used, they must be secured at both ends. Cables and raceways are not allowed to be supported by ceiling grids. For fire-rated assemblies, wiring located within the cavity of a fire-rated floor ceiling or roof ceiling assembly cannot be secured to or supported by the ceiling assembly, including the ceiling support wires. An independent means of secure support must be provided. When independent support wires are used, they must be distinguishable by color, tagging, or other effective means from those that are part of the fire-rated design. An exception to this is that the ceiling support system is permitted to support wiring and equipment that has been tested as part of the fire-rated assembly. A method of determining fire rating is testing in accordance with NFPA 251/1999 standard methods of tests of fire endurance of building construction and materials. For non-fire rated assemblies, wiring located within the cavity of a non-fire rated floor ceiling or roof ceiling assembly must not be secured to or supported by the ceiling assembly, including the ceiling support wires. An independent means of secure support must be provided. An exception is that the ceiling support system is permitted to support branch circuit wiring and associated equipment where installed in accordance with the ceiling system manufacturer's instructions. Furthermore, raceways can only be used as a means of support for other raceways, cables, or non-electric equipment under specific conditions. Firstly, where the raceway or means of support is identified for the purpose, or secondly, where the raceway contains power supply conductors for electrically controlled equipment and is used to support Class 2 circuit conductors or cables that are solely for the purpose of connection to the equipment control circuits, or thirdly, where the raceway is used to support boxes or conduit bodies in accordance with 314.23 or to support luminaires, which are fixtures, in accordance with 410.16. F. Cables are not allowed to be used as a means of support. Cable wiring methods must not be used as a means of support for other cables, raceways, or non-electrical equipment. The new reference in 800.24 essentially means that all communication circuits are now subject to the same wiring methods as systems carrying 120 volts, 240 volts, or 480 volts. This includes restrictions such as no longer being able to store excess wire on top of a pile or dropped ceiling, but instead, it must be secured. This also extends to maintaining the fire rating of walls and providing protection from physical damage. In places of assembly that have a certain number of people, which is a number that comes from the NFPA Life and Safety Code, all wiring must be run in conduit. In summary, the new requirements in 800.24 are designed to ensure the safe and reliable installation of communication circuits by mandating that they adhere to the same standards as power circuits. This includes proper support, protection from damage, and adherence to fire safety regulations. While there are exceptions for plenum spaces and existing buildings, the overall goal is to improve the quality and longevity of communication systems. The key takeaways from these requirements are: firstly, communication cables must be installed in a neat and workmanlike manner. Secondly, cables must be securely supported and protected from physical damage. Thirdly, in fire-rated assemblies, wiring must be independently supported and distinguishable from ceiling support wires. Fourthly, raceways can only be used to support other equipment under specific conditions. Fifthly, cable wiring methods cannot be used as a means of support for other cables or equipment. Finally, in certain places of assembly, wiring must be run in conduit. The intent of these rules is to minimize risks associated with communication wiring and to ensure that such wiring adheres to safety standards. By maintaining these standards, the performance and reliability of communication circuits can be greatly enhanced. It's worth emphasizing the importance of understanding the specific requirements for different types of installations, such as those in plenum spaces or existing buildings. The NEC provides detailed guidelines for these situations, and it's essential to consult the relevant sections to ensure compliance. Additionally, the reference to the NFPA Life and Safety Code highlights the need to consider the specific requirements for places of assembly, where the density of people may necessitate more stringent wiring methods. Changes to 800.24 reflect an increased focus on the overall safety and reliability of electrical and communication systems. By aligning the wiring methods for communication circuits with those of power circuits, the NEC aims to create a more consistent and safer electrical environment. Electrical inspectors and installers alike should familiarize themselves with these new requirements to ensure that all installations meet the current standards. Furthermore, the specific requirements outlined in 300.4 and 300.11 provide detailed guidance on how to properly support and protect cables and raceways. These sections are crucial for ensuring that wiring is installed in a manner that minimizes the risk of damage and ensures long-term reliability. The requirements for fire-rated and non-fire-rated assemblies are also important for maintaining the integrity of building fire protection systems. Understanding the distinctions between these types of assemblies and the corresponding wiring requirements is essential for ensuring compliance and preventing potential fire hazard. Finally, the restrictions on using cables as a means of support are aimed at preventing the overloading of wiring systems and ensuring that cables are properly supported to prevent sagging or damage. These restrictions contribute to the overall safety and reliability of electrical and communication installations. In summary, the updates to 800.24 of the NEC reflect a comprehensive effort to improve the safety and reliability of communication circuits. By adhering to these requirements, electrical installers can ensure that communication wiring is installed in a manner that minimizes risks, complies with fire safety regulations, and promotes the long-term performance of communication systems. The specific requirements outlined in the related sections of the NEC provide detailed guidance on how to achieve these goals. These changes highlight the importance of staying up to date with the latest electrical codes and standards to ensure that all installations meet the current safety and performance requirements. It is also important to note that the interpretation and enforcement of these codes may vary depending on local jurisdictions. It is always recommended to consult with local electrical inspectors to ensure compliance with all applicable regulations. In addition to the technical aspects of the code, it is important to consider the practical implications of these changes for electrical installers. The new requirements may necessitate changes in installation practices and may require the use of different materials or equipment. Electrical installers should be prepared to adapt to these changes and to invest in the necessary training and tools to ensure that they can comply with the new requirements. The focus on independent support for wiring in fire-rated assemblies is particularly important. This requirement is designed to prevent the collapse of ceiling systems in the event of a fire, which could compromise the integrity of the fire-rated assembly and allow fire to spread more quickly. By ensuring that wiring is independently supported, the NEC aims to maintain the effectiveness of fire protection systems and to protect building occupants. The restrictions on using ceiling grids to support wiring are also important for preventing overloading of the ceiling system. Overloading can cause the ceiling to sag or collapse, which can create a safety hazard and damage the wiring. By requiring independent support for wiring, the NEC aims to prevent these problems and to ensure the structural integrity of the ceiling system. In addition to the specific requirements outlined in the NEC, it is important to follow industry best practices for electrical installations. This includes using high-quality materials, following manufacturer's instructions, and performing thorough inspections to ensure that the installation is safe and reliable. It is also important to provide adequate training for electrical installers to ensure that they are knowledgeable about the latest codes and standards and that they have the skills and experience necessary to perform high-quality installations. The new requirements in 800.24 of the NEC represent a significant step forward in improving the safety and reliability of communication circuits. By adhering to these requirements and following industry best practices, electrical installers can help to create safer and more reliable electrical environments for building occupants. Remember to consult the NEC and local codes for the most up-to-date information and guidance on electrical installations. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding and bonding are essential for preventing electrical shock hazards and for ensuring the proper operation of electrical equipment. The NEC contains detailed requirements for grounding and bonding, and it is important to follow these requirements carefully to ensure the safety of electrical installations. Surge protection is another important aspect of electrical safety. Surges can damage sensitive electronic equipment and can even cause fires. The NEC contains requirements for surge protection, and it is important to install surge protective devices in accordance with these requirements to protect electrical equipment from damage. Arc fault circuit interrupters or arc fault circuit interrupters are designed to detect arc faults, which are a common cause of electrical fires. Arc fault circuit interrupters can help to prevent electrical fires by detecting arc faults and interrupting the circuit before a fire can start. The NEC requires the use of arc fault circuit interrupters in certain locations, such as bedrooms, and it is important to install arc fault circuit interrupters in accordance with these requirements to protect against electrical fires. Ground fault circuit interrupters, or ground fault circuit interrupters, are designed to detect ground faults, which are another common cause of electrical shock hazards. Ground fault circuit interrupters can help to prevent electrical shock hazards by detecting ground faults and interrupting the circuit before a person can be injured. The NEC requires the use of ground fault circuit interrupters in certain locations, such as bathrooms and kitchens, and it is important to install ground fault circuit interrupters in accordance with these requirements to protect against electrical shock hazards. In addition to the specific requirements outlined in the NEC, it is important to follow general safety precautions when working with electricity. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and avoiding contact with live electrical circuits. It is also important to de-energize electrical circuits before working on them and to use lockout-tagout procedures to prevent accidental energization. By following these safety precautions, electrical workers can minimize the risk of electrical shock and other electrical hazards. Electrical safety is a critical concern for everyone, and it is important to take steps to ensure that electrical installations are safe and reliable. By following the requirements of the NEC, following industry best practices, and following general safety precautions, we can all help to prevent electrical accidents and to protect ourselves and others from electrical hazards.